Okay, this is a video that we're going to be going over where we talk about some applications of integration, and probably the first and most basic application of definite integrals is to compute areas. So I want you to look at this particular integral here. We have a definite integral, you see at the bottom of your screen, the integral from 0 to 4 of 1/3 times parentheses x cubed minus 5x squared plus 2x plus 8 close parentheses dx. So take that integral and interpret it in terms of area and illustrate it. Okay? As we go through these series of videos, I'm going to ask you to work through I'm going to present a problem, then ask you to work through it yourself, and then we're going to go back and check your answer as we proceed through. So I'll be asking you to pause the video as we go along. So let's go ahead and do that now. Work through this one. Come back when you're done. Press pause now. Okay, well hopefully you not only worked out what this integral is, but then we also interpret it in the value in the problem, the context of the problem, which is just computing an area. So we want to graph this function here, 1/3 of x cubed minus 5x squared plus 2x plus 8. Here I used Graphmatica on the graph that you see here, but you could do this in your graphing calculator, for example. And then we're going to figure out what this is on the calculator by going through this. A couple things things that we can do with this. Let me pull up my calculator here. So I can take this and put the function in, 1/3 x cubed minus 5x minus 5x squared plus 2x plus 8 close parentheses. And we can just graph this, and we're interested from 0 to 4, so we might as well set our window up running from 0 to 4. And we can do that. Let's just see what the graph looks like. We may want to change it a little bit on the vertical. Another thing you can do is, if you've got the x's set, I believe Zoom Fit will adjust the y's for you if you have the x's set. So I think this will leave the x's alone and sort of fit the y's in there. I think it's a pretty nice window. And if we want to do this integral, we can calculate it by doing second trace, which is calc, choosing number 7 here. And we want to integrate from 0, enter, to 4, enter. And notice it's going to shade this. Now what it's going to compute, of course, is this area above the x-axis minus the area below the x-axis, which we can look at here. Okay, let's just clean this up just a teeny bit before I move on. And let's go ahead and put what it was that we put in. And let's put in what the window is. Kind of a strange window there. If we wanted to, we could go maybe something smaller or larger, but this is what a Zoom Fit gives us. Let's go with that. Okay, so you can see there some what it is on the calculator. So we're doing this blue area minus the red area is how we interpret it. And here we can find that exactly and approximately. Here we could find it approximately with the calculator. We can also do it on the calculator from the home screen. Well, you can see what I've done here. Let me do it this way with the newer operating system, Math 9, and plug it in basically like it looks. So we're going from 0 to, what was it, 4? Yeah, 0 to 4. And since I have it in here, I can just do y1 dx, and there it is, and I can change that to a fraction. So 16/9 is exactly what I get. And that's what it looks like on the newer operating system. Okay. So 16/9 actually turns out to be the exact value. We can see that without a calculator by going and doing the integral by hand here. So let's work through the steps of that. We pull the 1/3 out front. Then we just take the antiderivative of each of the piece using the sum rule, and it's just the power rule. So just add 1 to the power, multiply by the new power. So 3 plus 1 is 4, multiply by its reciprocal, which is 1/4. Power 2 goes up to power 3, multiply by the reciprocal, which is 1/3. So that's -5/3. Power here goes up to 2, multiply by the reciprocal, which is 1/2 times the 2 is 1. And if it's a constant term, it picks up an x. So it's 8x. Derivative of 8x is 8. And we're going to evaluate that from 0 to 4. So the 1/3 I have out front times the whole thing. Then notice the importance of this bracket right here, parentheses there. And then we have this right here. Just copy that down and put 4 in place of all the x's. Minus, copy that down here in parentheses, and put 0 in place of all the x's. And all of this last part is just 0. Let's see. I got 4 4's here, and one of them was going to cancel with that. So I get 4 to the 3rd, which is 64. Here I get 4 cubed, which is 64. Again, times -5 is -320 over 3. Over that 3 there. And 4 squared is 16. 4 times 8 is 32. The rest of this is all 0. Adding all that together, 64 plus 16. So that's 80 plus 32 is 112. Get a common denominator by multiplying 112 by 3 over 3. That's 336 over 3. Now add these together by keeping the denominator. 336 minus 320 is 16. 3 times 3 is 9. 1 times 16 is 16. And so the exact answer is 16/9, or do some long division and get 1.7 repeating for a decimal form. So this can be done without using a calculator at all. Of course, you could graph it without a calculator, or you could use technology to graph or to compute the answer there for an area. So notice, though, that what we get here is a net area. It's not both of those areas added together. It's actually the area above the x-axis minus the one below. Okay? But in each case, it's the area between the curve and the x-axis. So blue area minus red area is what we interpret there. So let's take this same one, the same function. What's the total area here? In other words, how would we find all of this added together? Well, we can think of that as sort of two different ways. We could think of doing the integral from 0 to wherever this crosses the x-axis, and then take that area. That would be this one. And then we go from here to here, we're going to get a negative, but take the opposite of that will be this area, and then add those two together. So one of the things that's going to be interesting is finding where that crosses the x-axis, which is solving the equation, this formula, this cubic formula, equal to 0. Turns out it's got a nice number. It's just 2. And so we can kind of check that. Sure enough, if I plug in 2, it looks like 2 on the graph, but if I plug in 2, Here you see the details worked out right here. 2 cubed is 8. 2 squared is 4 times 5 is negative 20. 2 times 2 is 4. And let's see. 8 plus 8 is 16, plus 4 more is 20, minus 20 is 0. 0 times 1/3 is, sure enough, 0. So we want this blue area here plus the blue area down here. If we just integrate, we're going to get subtracting. So we need to integrate the first part minus the integral of the second part. Or, equivalently, integrate the absolute value. Now, when you do the absolute value of the function, it takes the part that's below the x-axis, flips it above the x-axis, and you're finding the area under this green curve here, which is the absolute value of the original function. So I can use a calculator technique and say that's the function integrate or the numerical integral of the absolute value of 1/3 x cubed plus 5x squared plus 2x plus 8, and work that out. Here's the way it would look. Since I've got it in y1, I could do, let's see, I can actually just go up here and just do this. Grab this guy, but I want to put in right here, insert math absolute value. Then actually I want the y1 to be right there. So I'm going to get rid of this other y1. There we go. And this will give me the exact answer. In fact, because when I change it to fraction, that's the exact answer. Okay. So there it is in the newer operating system, or the older one here. If we wanted to do that by hand now, what would we have to do? Well, we're actually integrating the absolute value of the function. But the absolute value is a piecewise function, so you have to figure out where it crosses the x-axis and change its sign and break it there. So from 0 to 2, this function here is positive, so the absolute value of it is just the same function without the absolute value. But if you're integrating from 2 to 4, this function is below the x-axis. So when you have a negative number, the absolute value is the opposite. So I have the opposite of that, which I put out front. Okay? So again, it's the same antiderivative we found before, here and here. Okay? But this time we go from 0 to 2, and this time 2 to 4, but we have a minus right here, plus over here. So let's do this first one, I get 1/3, plug in 2 here, 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 and here. That's this part. Minus, parentheses, plug in 0 at all those places. Okay, and here we have minus 1/3, and I have no idea why I have exactly the same line copied twice. We can get rid of that. Okay. And then minus 1/3 here, and put the 4 here and the 2 there. Okay, so let's see what we get here. 2 to the 4th is 16, divided by 4 is 4. This is 2 to the 3rd is 8, times negative 5 is negative 40, and that's over 3. 2 squared is 4, 2 times 8 is 16. Minus, well, all that part's 0. Then we got minus 1/3 times, I factored that out here and here. Now what's left? Well, I've got the 1/4 here. Let's see, so what's the 4 here? 4 to the 4th, well, that cancels one of those 4s. You get 4 cubed, which is 64. 4 cubed again is 64, times negative 5 is negative 320, and that's over 3. 4 squared is 16. 4 times 8 is 32. Now I'm going to distribute the minus as I go here. 2 to the 4th is 16, divided by 4 is 4, but then it's positive 4, but then that negative right there makes it minus 4. 2 cubed is 8, times negative 5 is negative 40 over 3, but that negative makes it plus 40 over 3 right here. Then I got 2 squared is 4, positive, but that negative there makes it negative 4. 2 times 8 is positive 16, but that negative makes it negative 16. So combining here, 4 plus 4 is 8, plus 16 is 24, minus 40/3. Here we get 64 plus 16 is 80, plus, well, actually the 16's just cancel. Let's do that. And let's see. So this is 80, 64 and 32 is 96. Minus 4 is 92. Minus 4 more is 88. Okay, that looks good. And to get a common denominator here, multiply by 3 over 3, so 73 over 3. And this is 88 times 3 is 264, so it's 264 over 3. 72 minus 40 is 32. 264 minus 280 is negative 16. So this becomes plus 16 over 9. You're multiplying the numerators and multiplying the denominators here. And this is 32 over 9. So 16 plus 32 is 48. 48 over 9, I can cancel 3 out, and that becomes 16 over 3. So in reduced form, the final correct answer is 16/3, or 5.3 repeating. In this particular case, this being a cubic, Simpson's rule is going to work perfectly, so you should get an exact answer out of your calculator, which we did. Okay, we'll talk a little bit about how symmetry can help us in our next video.